Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. In this second video lecture of week 11 for the course Numerical Analysis, today we are going to learn about solution of system of linear equations by LU decomposition method. And in LU decomposition method, today we are going to discuss the Cholesky method. So this second video lecture is the continuation of my previous first video lecture of week 11. In first video lecture of week 11, we have already discussed the solution of system of linear equations by LU decomposition method, and in LU decomposition method we have discussed the do little methods and Crowd's method for the solution of system of linear equations. And now in this video lecture we are going to discuss another method which is called Cholesky method. So for example, solution of system of equation by symmetric factorizations. This method is based on the idea of decomposition the symmetric matrix A of the system into the product of a lower triangular matrix and its transposition matrix, or into the product of an upper triangular matrix and its transposition matrix. So dear students, symmetric factorizations actually called the Cholesky method. Suppose we have a function of we have a system of linear equation Ax is equal to b, where A is the coefficient matrix, x is the unknown matrix, and b is the constant which lies at the right hand side of the system. Now there are some steps for the procedures of Cholesky method. First of all, find the lower triangular matrix and the transpose of the lower triangular matrix such that L into L transpose is equal to A. And now in the second step, find the column matrix Y, Y1, Y2, Y3 up to Yn. So actually this is written in the form of the transpose. So we need the column matrix Y, which obtain the unknown Y1, Y2, Y3 up to Yn, and use L transpose into Y matrix is equal to B. So from this step we can find the column matrix Y. And now use the column matrix Y and the lower triangular matrix L and find the unknown matrix X by using this equation Lx is equal to Y. For example, to solve this system by symmetric factorization. By symmetric factorization mean to solve the system by Cholesky method. And you see over here, this is the first equation of the system, 9x1 plus 3x2 minus 3x3 is equal to 4, and the second equation 3x1 plus 17x2 plus 3x3 is equal to minus 3, and the third equation minus 3x1 plus 3x2 plus 27x3 is equal to 6. Now write the system in matrix form. You see over here, this is the augmented matrix, this is the unknown matrix, and this is the constant matrix. Now factorize this matrix A into two matrices. One is the lower triangular matrix and other is the transpose of the lower triangular matrix. So you see over here, dear students, this is the lower triangular matrix L11 0 0, L21 L22 0, L31 L32 and L33. So this is the lower triangular matrix, and this is the transpose of this lower triangular matrix. So this is equal to A, and I have already told you in the do little methods and the Crowd's method that in the do little methods and the Crowd's method we use the lower triangular matrix and the upper triangular matrix. So you see over here, this is also the lower triangular matrix and this is the upper triangular matrix, but in this case we put the diagonal entries in the lower triangular matrix unknown, and that same entries which will be lies on the upper triangular matrix at the diagonal entries. Like you see over here, L11, L22 and L33, and the diagonal entries of the upper triangular matrix is also L11, L22 and L33. But in the Doolittle methods, we obtain in the diagonal of the lower triangular matrix 1, 1, 1, and at the upper triangular matrix at the diagonal we obtain the unknown. And similarly in the Crowd's method, we obtained the unknown at the diagonal of the lower triangular matrix and 1, 1, 1 at the diagonal of the upper triangular matrix. But in the Cholesky method, the diagonal entries of the both matrices will be unknown and will be same, like you see over here, L11, L22, L33. So these unknown presentations will be same. So this is the lower triangular matrix, and this is the transpose of the matrix. So the diagonal entries will be the same, L11, L22, L33, and L11, L22 and L33. These diagonal entries are same, but now here this is unknown. So this is the lower triangular matrix, and this is the transpose of the lower triangular matrix, and this is the matrix A. Now multiplied these two matrices, you see over here. After multiplications, compare this matrix with this noun matrix, we can find, like you see over here, to find the first row with the second column, L11 square is equal to 9, and then for multiply the first row with the second column, L11 L21 is equal to 3, and the first row with the third column, L11 L31 is equal to -3. So you see over here, L11 square is equal to 9, so taking the square root, L11 is equal to 3, and L11 L21 is equal to 3. So putting the value of L11, which is also 3, and after simplification we obtain L21 is equal to 1. Now L11 L31 is equal to -3, putting the value of L11, which is 3, so L31 is equal to -1. And similarly L21 square plus L22 square is equal to 17. So putting the value of L21, the value of L21 you see over here is 1, so putting here 1. Now L22 is equal to 16, and taking the square root, we obtain L22 is equal to 4. Similarly L21 L31 plus L22 L32 is equal to 3, and putting the value of L21 L32 L31 and L22, we obtain L32 is equal to 1, and L31 square plus L32 square plus L33 square is equal to 27. Now putting the value of L31, putting the value of L32, we obtain L33 square is equal to 25, and taking the square root, L33 is equal to 5. So dear students, first of all, multiplied these two matrices, you will obtain a single matrix, and then that single matrix of 3 by 3 order compare with this 3 by 3 order matrix, and you can find the unknown entries in the lower triangular matrix, like you see over here. So these are the we have find now the unknown for the lower triangular matrix, L11, L22 and L33, and this is the L21, and this is L31, L32, and this is L33. Now taking the transpose of these this matrix, so this is actually the lower triangular matrix, and this is the upper triangular matrix, and you see over here the diagonal entries are same, 3, 4, 5. So 3, 4, 5, and just you can find the transpose of the lower triangular matrix, you will obtain the upper triangular matrix. Now to find the column matrix Y, use Ly is equal to B, Ly is equal to B. Now multiplying these two matrices and write the matrix in equation form, by forward substitution we obtain 3y1 is equal to 4, so y1 is equal to 4 by 3, and in the second equation y1 plus 4y2 is equal to minus 3. Now putting the value of y1, we obtain 4 by 3 plus 4y2 minus 3, and taking the LCM after simplification we obtain y2 is equal to minus 13 by 12. And the third equation minus y1 plus y2 plus 5y3 is equal to 6. Now putting the values of unknown y1, putting the value of known variable like y1 is equal to 4 by 3 and y2 is equal to minus 13 by 12. So putting these value in this equation, putting the value of y1, putting the value of y2, we obtain y3 is equal to 101 divided by 60. So this is the column matrix y. Now putting the column matrix y for in this equation, L transpose into X is equal to y. This is the transpose of the lower triangular matrix, and this is the unknown matrix, and this is the y matrix. Now from the back substitutions we obtain 5x3 is equal to 101 divided by 60, and dividing both sides by 5 we obtain x3 is equal to 101 divided by 300. Similarly 4x2 plus x3 is equal to minus 13 by 12. So putting the value of x3, we obtain x2 is equal to minus 426 divided by 1200, and in the first equation 3x1 plus x2 minus x3 is equal to 4 by 3. Putting the value of x2 and the value of x3 after simplification we obtain x1 is equal to 6830 divided by 3600. So this is actually the solution of the given system of linear equation. Now another example by Cholesky method. Suppose 9x1 plus 3x2 minus 3x3 is equal to 4. 3x1 plus 17x2 plus 3x3 is equal to minus 3, and the third equation minus 3x1 plus 3x2 plus 27x3 is equal to 6. So write the system in matrix form, and now this is the coefficient matrix. Now decompose, factorize this coefficient matrix into the lower triangular matrix and the transpose of the lower triangular matrix. This is actually also called the symmetric factorization. Now this is the lower triangular matrix, and this is the transpose of the lower triangular matrix, and this is the matrix A. Now multiply these two matrices and you will obtain a single matrix, and then compare the single matrix to this known matrix A. You can easily find L11 square is equal to 9. So taking the square root, L11 is equal to 3. Similarly L11 L21 is equal to 3, and the L11 value is 1, so L21 is equal to 1, and the other unknown like L11 L31 is equal to minus 3. Putting the value of L11 which is 3, and 3 divided by 3 we obtain L31 is equal to minus 1. So dear students, actually you see over here, this is the solution of the previous example. Both examples are same, but I would like to repeat the procedure of the Cholesky method. So in Cholesky method, first of all take the lower triangular matrix and then take the transpose of the lower triangular matrix. This is the lower triangular matrix, and this will be the upper triangular matrix. So dear students, I would like to tell you again that we have three methods in the LU decomposition method for the solution of system of linear equation. One is the Doolittle method, other is the Crowd's method, and third one is the Cholesky method. In the Doolittle method, these diagonal entries are 1 1 1, and in the upper triangular matrix these diagonal entries will be unknown. Similarly, in the Crowd's method, these diagonal entries of the lower triangular matrix will be unknown, and the diagonal entries of the upper triangular matrix will be 1 1 and 1. And similarly, in the Cholesky method, these diagonal entries of the lower triangular matrix and the diagonal entries of the upper triangular matrix will be unknown, n will be same presentations: L11, L22, L33, L11, L22 and L33. So in simple, we can say that this is the lower triangular matrix, and take the transpose of the lower triangular matrix, you will obtain the upper triangular matrix. Now multiplying these two matrices, you will obtain a single matrix, and then compare this single matrix to this single matrix. You can easily find these unknown L11, L22, L33, L21, L31 and L32. So you see over here, this is actually the comparisons, and I have already told you in the previous slides for this comparisons. Now this is actually the lower triangular matrix, and this is the transpose of the lower triangular matrix. Now then find in step number 2 the column matrix Y by using the column matrix Y by using this expression Ly is equal to B. This is the lower triangular matrix, this is the column matrix Y, and this is the matrix B. Now using the forward substitutions, you can find the value of y1. 3y1 is equal to 4, so y1 is equal to 4 by 3, and in the second equation y1 plus 4y2 is equal to minus 3. Putting the value of y1, you can easily find the value of y2 is equal to minus 13 by 12, and in the last equation minus y1 plus y2 plus 5y3 is equal to 6. Putting the value of y2 and the value of y3, we can find the value of y1 is equal to 101 divided by 60. Now in the last step, use this equation L transpose X is equal to Y. This is the transpose of the lower triangular matrix, and this is the unknown matrix x1, x2 and x3, and this is the Y matrix. Now using the back substitutions. In the second step, use the forward substitution, find the column matrix Y, and in the third steps, use the backward substitutions. Dear students, note that in the second step, use the forward substitutions for the column matrix Y, and in the second step, use the backward substitution for the unknown matrix X. So by backward substitutions, we obtain x3 is equal to 5x3 is equal to 101 divided by 60. So x3 is equal to 101 divided by 300, and the second equation 4x2 plus x3 is equal to minus 13 by 12. So putting the value of x3, we obtain the x2 is equal to minus 426 divided by 1200. Similarly, in the first equation 3x1 plus x2 minus x3 is equal to 4 by 3. Now putting the value of x2 and the value of x3, we obtain x1 is equal to 6830 divided by 3600. So this is the solution of this given system of linear equation. So dear students, the Cholesky method is very simple. First of all, write the system in matrix form. You see over here, I want to tell you again the procedure. First of all, write the system in matrix form, and then decompose the augmented matrix, decompose the coefficient matrix into two matrices. One is the lower triangular matrix, and other is the transpose of the lower triangular matrix. So this method is very simple. Now multiply these two matrices, you will obtain a single matrix, and then by comparisons, find the unknown, these 6 unknown, L11, L22, L33, L21, L31 and L32. So when you find these 6 unknown, then putting the 6 unknown in this matrix, you will obtain the lower triangular matrix, and taking directly the transpose of the lower triangular matrix, you can easily find the upper triangular matrix. So this is the L matrix and this is the upper triangular matrix, but this is actually the transpose of the lower triangular matrix. Now use step number 2, Ly is equal to B. This is the lower triangular matrix, this is the unknown Y matrix, and this is the B matrix. Now using the forward substitutions, find the Y matrix in which y1, y2 and y3 are unknown. Then when you find the unknown matrix Y for y1, y2 and y3, then use this step number 3, L transpose into unknown matrix X is equal to Y, putting the value of the transpose of the matrix L, the value of the Y matrix, and you can easily find the unknown matrix X by using the backward substitutions. Now this is the end of this segment. Thank you. Allah Hafiz.